Today, we're going to be going over the last of the identities that we're going to do here in pre-cal, which is sum and difference formulas and the double angle formulas. We'll start with the sum and difference. These are the sum and difference formulas that you can use for identities, for verifying identities, just like we've used the other formulas. It tells us that when we have the sine of one angle plus the other, it is equal to the sine of the first, cosine of the second, plus the cosine of the first times the sine of the second. It is going to be the same for first angle minus the second one, except the sign here is going to be a negative. For cosine with a plus, so the sum of these, it's going to be cosine of the first times cosine of the second minus sine of the first, sine of the second. And then again, we'll have the same thing, but in this case, if it is minus, it is a plus here. These formulas will be provided for you for the test. We are going to use these mostly to find an actual value. So we're going to be finding the exact values using these formulas. Again, they can be used for verifying identities as well, but mostly we're going to use them to find exact values. Now, in some cases, that gets a little bit tricky, especially for you guys that struggle with fractions. For example, if they're asking for 11 pi over 12, this is not on the unit circle. So if I was doing the sum of two angles here, I would have to get it to unit circle values. So I would do something like 9 pi over 12 plus 2 pi over 12, which reduces, both of these can be reduced by 3. So that would be 3 pi over 4. And then this would be pi over 6. Those two are on the unit circle. And so that would be the sum that I would put in there. So we can change from the sine of 11 pi over 12 to the sine of 9 pi over 12 plus 2 pi over 12, which reduces to this, and then we can go ahead and simplify that. So we're going to try some, and we'll do them with both degrees and radians. The degrees are a little bit easier because you guys are used to subtracting and adding numbers. With subtraction, so something like 1 pi over 12, we can change that to 4 pi over 12 minus 3 pi over 12. Those two reduce. I can reduce this one by 4 on both of those, and that becomes pi over 3. I can reduce both of these by 3, and that would give me pi over 4. So those are going to be the ones that are a little bit harder as the radian ones. So we'll go ahead and start with degrees. It says find the exact value of the cosine of 75. 75 is not on the unit circle, but I can go ahead and use some of these sum and difference formulas or identities in order to solve that. I can set this up as the cosine of two different angles that are on the unit circle and get that. And we can do that with either the sum formula or the difference formula. And there is more than one that you can possibly use. I'll go ahead and do 135 degrees minus 60 degrees. So both of these are on the unit circle. Now this would be the same as this one right here, the cosine of 135 minus 60 degrees. So I can use this formula to find the exact value by doing that. So here we go. We're using the cosine of 135 degrees, because that's my first angle, times the cosine of 60 degrees, because that's my second angle, plus the sine of 135, because that's my first angle, and sine of 60 degrees, because that's my second angle. So this was my first angle, I plugged it in right there. Second angle, I plugged it in right there. Now we can simplify. You know that unit circle well, or you should, and so you can get those values for the unit circle to plug in here. So the cosine of 135, well, that's negative root 2 over 2. The cosine of 60, that's 1/2, plus the sine of 135, that's root 2 over 2. And the sine of 60, that's root 3 over 2. Now we simplify. When we multiply fractions, remember you're multiplying straight across, so this is going to give me a negative root 2 over 4. Over here we get a root 6 over 4. Root 2 times root 3 gives me root 6, and 2 times 2 is 4. We simplify these. Since they are not the same, I can't really put them together, so that will be negative root 2 plus root 6. Oops, sorry about that. That didn't look very good. So here we go. Root 6 over 4. And I can add those because they are a common denominator there. And so that would be my value. All right. I'm going to try a sum one just so you could see that one. Also a sine. This one was cosine. Let's try a sine one. So find the exact value of sine 105. We know that the sine of 105 can also be the sine. The sine of 105 is the same as sine of 60 degrees plus 45 degrees. Both of those are found on the unit circle, so those we can go ahead and simplify. So we're going to do sine of my first angle, which is 60 degrees, times the cosine of my second, which is 45 degrees, plus cosine of my first angle, which is 60, and then sine of my second, which is 45 degrees. I went ahead and used the sum, so that sine of my first plus my second is going to be sine of first, cosine of second, plus cosine of second, sine of the second. So cosine of the first, sine of the second. All right, now this is from the unit circle from this point, which you should know well, so we're going to set up our parentheses here. And the sine of 60 degrees is root 3 over 2. Cosine of 45 is root 2 over 2. Cosine of 60 is 1/2, and the sine of 45 is root 2 over 2. From that point, it's just simplifying. So we multiply and we get root 6 over 4. Over here we multiply and we get root 2 over 4. We combine our like terms, which in this case, those are not like up on top, and we keep our denominator, which is 4. So there is our degrees for the sum and difference. Now we're going to go ahead and try the radians. Again, that one's a little bit harder for students just because it's fractions. I went ahead and used the same examples up on top that we did just so that it make it a little bit easier. So we're going to find the exact value of sine of 11 pi over 12, sorry. And so that's the one that we used up here. 11 pi over 12, and that was 3 pi over 4 plus pi over 6. We're going to set it up exactly like we did with the degrees. So we're going to use our sum of the sine ones. And so with the sine for the sum, it tells us to do the sine of the first one. So I'm going to do sine of 3 pi over 4, cosine of the second, plus cosine of the first, sine of the second. So all you're doing is plugging in the information into your formula there. We were using that sum because we were adding those two right there, so we use this formula right here. Now the rest is that unit circle. Again, you should know that really well. And so that is root 2 over 2. Pi over 6 is root 3 over 2. Now we're going to go ahead and add the cosine of 3 pi over 4 is negative root 2 over 2. Remember, that's in the second quadrant for cosine, which is negative. And then pi over 6 is 1/2. We multiply across. That gives us root 6 over 4. That's going to be a negative because the negative times a positive gives us a negative, and then root 2 times 1 gives us root 2 over 4. You're probably thinking those numbers look very similar. They do. Like this one right here is just like this one. And those numbers are always going to come out kind of the same because if you remember on the unit circle, those values all are the same. So it's just the way you're multiplying or subtracting them. All right, for our next one here, we're going to do a subtraction one. We'll do the cosine. And so that is pi over 3 minus pi over 4 because we did that one up there. That was this one right here. And so we're doing the difference of cosines. So right here's my difference. So I'm going to do cosine of the first, cosine of the second, plus sine of the first, sine of the second. So we get cosine pi over 3 times cosine pi over 4. And then we've got a plus sine of my first, sine of my second. Unit circle again. So now we're ready to put in our unit circle values. And so we get 1/2 and root 2 over 2. The sine of pi over 3, that's root 3 over 2. And then we've got the sine of pi over 4, which is root 2 over 2. We multiply across. And then we add. And there we go. So here you just need to be careful to use the correct formula, the sum one for the sums and the difference one for the differences, and then plug in and make sure you're using your correct unit circle values so that you get the correct answer. All right, so we are going to work backwards on the next two just to show you some other types of questions for it. This one says find the exact value, and it gives us the sine of 42 times the cosine of 12 minus cosine of 42 sine of 12. Well, none of those values are on the unit circle, so we can't really do it that way, but we can work backwards. This is sine of an angle and then cosine of an angle, so I know it's going to be one of these two right here. Then it was a minus in between here, so the one with the minus is this one. So I would want to convert back to this side because that might help me. So that is sine of the first angle minus sine of the second one. So I get the sine of 42 degrees minus 12 degrees. When I simplify that, I get sine of 30 degrees, and that is something that's on the unit circle, and then we're able to solve. So from the identities, you can work one direction like this one when it doesn't work to try and get it to something on the unit circle that we can answer, or you can go from something smaller like this that's not on the unit circle, convert it to something that is so that you can get the final answer. And so the sine of 30 is 1/2. All right, here's another one. In this case, they're cosine, cosine, and then sine, sine. And so cosine, cosine, and sine, sine is our cosine ones. And that was a negative in between there, so that's going to be this one. So it's going to be the cosine of those two angles to add together. So cosine of 25 degrees plus 20 degrees. That is the cosine of 45 degrees, which is on the unit circle. That's our root 2 over 2. So there's the sum and difference of angles. You can use them to verify identities, but mostly we're going to use it to find exact values. All right, the next part we're going to discuss is our double angle identities. And these are the last formulas that you've got there on your formula chart. By double angle identities, we're talking about the angle being multiplied times 2. So that's what you're going to see there. That's the sine with the angle multiplied times 2, cosine with the angle multiplied by 2, and then our tangent with the angle multiplied by 2. And so those are the ones we're going to look at next. All right, so let's get started with this. It says, given sine of theta is equal to 4/5. And we're looking at an angle that's between pi over 2 and pi. Solve the following. So the first thing I'm going to want to do here is draw my triangle. Since it is between pi over 2 and pi, I know pi over 2 is 90 and pi is 180 right here. So it's in this second quadrant. If you draw it in the correct one, it'll give you your correct sign. So that's why that's important. And sine is opposite over hypotenuse. And so my opposite is going to be 4 and my hypotenuse is going to be 5. And then you can use Pythagorean theorem, or you can go ahead and realize that's a 3, 4, 5. So this would be a -3 since it's in the second quadrant. Now with our double angles, notice that with sine, I need sine and cosine. With cosine, I need cosine and sine again, or I can do the cosine by itself. And then with tangent, I need the tangent values. So I'm going to go ahead and write those out to the side since I know I'm going to need them anyway. So my cosine of theta here is adjacent over hypotenuse. So I would do the -3 over 5. And then tangent we know is opposite over adjacent, so we get a -4/3. So I'm going to leave those there so that when we're working the actual formula, we can just go ahead and plug them in. All right, the first one we're going to do is the sine of 2 theta. So it tells us that with sine of 2 theta, we want 2 sine theta cosine theta. Again, these you can use for verifications as well, but we're mostly going to use them to find the actual angles values. So sine of 2 theta is 2 sine theta cosine theta. So I would do 2. The sine of theta was given to us. That's 4/5. And then our cosine of theta, we wrote right here to be -3/5. Now it's just simplifying. And so when I multiply here, I get a -12 over 25. And we know that whole numbers are over 1, so that's really over 1. So I would multiply 2 times -12, which is -24, and 1 times 25, which is -24/5. So that would be our sine of 2 theta, our double angle. All right, the cosine one is kind of strange for students because there are 3 different formulas here. That just means you can use whichever one's the easiest. If the cosine was given to me right here and I was asked for the cosine of 2 theta like this, then I would go ahead and use this one because they already gave me the cosine so I can easily plug it in. If they give me the sine like this one, I think the easiest one to use is this one because that's the one that requires a sine formula. If you've got both of them, you can do that one. All right, so I'm gonna use this particular one because if I was only answering this question, that's what I would do since the sine of theta was given to me. So 1 minus 2 sine squared of theta. And so we get 1 minus 2 times the sine of theta. And so that was given as 4/5. And it is squared. So I'm going to take care of the squaring first for order of operations, and so that gives me 16 over 25. Then I multiply that 2, and so we get -32 over 25. And when we combine something like this, we have to get a common denominator. So 1's the same thing as 25 over 25, so that would be -7 over 25. Now I am going to go ahead and show you that it doesn't matter which formula you use, you're going to get the same exact answer. So we'll go ahead and do another one. So if I did the 2 cosine squared of theta minus 1, the cosine we had was -3/5, so I'm going to put that in for my cosine value, and it is squared, so I'm going to take care of that first. -3/5 times -3/5 gives me 9 over 25. Now we multiply our 2, and so that's going to give me 18 over 25 minus 1. And then 1 is the same thing as 25 over 25, and so that would be -7 over 25. So the math itself looks a little bit different here, but we did get exactly the same answer. So it doesn't matter which formula you choose to use, so choose whichever one's going to be easiest for you. All right, our last one, a tangent. Tangent always seems to be a little bit harder than the others, so it is a fraction here when you're doing that double angle. But again, we're just going to start plugging things in. So I've got 2 times the tangent of theta and 1 minus tangent squared. We found the tangent to be -4/3. So we're going to put that in. Now we start to simplify. So up in the numerator, I'm going to multiply across and I get -8/3. And the bottom here, we need to square. So I'm going to get 1 minus 16 over 9. Now, in order to do keep, change, flip, you have to have one fraction on the top and one on the bottom. So we're going to go ahead and combine these two. That means I have to get that common denominator again. And so our common denominator between these two would be 9. So 9 over 9 minus 16 over 9. Go ahead and write that so you can see what we're doing there. That gives me -8/3 over -7/9. Now we can do the keep, change, flip. So I keep my -8/3, I change to multiplication, and I flip my bottom fraction. Now a negative times a negative is going to be a positive. And in this case here, I'm going to go ahead and reduce this 3 and this 9 to 3 just so it makes it a little bit easier. So I get 24 over 7. There's our tangent of a double angle. So those were our last identities that we needed to cover for this unit. We've got all of the identities from before, and then the sum and difference and the double angle identities. Again, the sum and difference and double angle you'll be given, so you just need to know how to use them. The other ones you should already getting to memorize them since you've used them so much.